Alright, I know we're skipping a lot of pages in our notes. We're going to look at 8.4. Our master learning objective is I can identify the features of a rational expression by understanding the relationship between the asymptotes and other features. Okay. So the first thing that we are looking at here then is what is an asymptote. And an asymptote is a line that a graph gets close, we'll say closer and closer to but never touches / crosses. Yeah. Alright, a line that a graph gets closer and closer to but never touches / crosses. So, what are features of a rational function? So, our rational functions have two types of asymptotes. They have vertical asymptotes and horizontal asymptotes. So you can see here how this graph is split. If you look here, this is going to start going straight up, and this is going to start going straight down. Neither of these are ever going to actually touch or cross this line right here. Okay. A vertical asymptote is always x equals a number. Okay. In this case, it's at x equals 0, right? I think of my asymptotes as fences, right? They're keeping in the function. Then for my horizontal asymptote, same thing, right? Our blue graph is never going to actually cross that line right there. Horizontal asymptotes are always y equals a number. If you tell me just the number and not the x equals or y equals, that's incorrect. Okay, it's a line, so it has to be the equation of a line, so it has to have an equals. So this is y equals 0. Okay, so this is what we would call our parent function for this. What was I going to say? So this is with 0 and 0, that's your most basic. We'll see some others. So then your domain, remember, your domain is all your possible x values. So as I walk along my x-axis, right here at x equals 0, I can't keep walking. There's a fence in the way. So what happens is I can have everything from negative infinity until I hit that fence. I jump over the fence, and then I keep walking forever. Right? So you have to jump the fence of your asymptote. Same thing for our range. Okay, again, range always goes from bottom to top. That was one of the things we got off on our last from, I can't spell it all. Let's try that again. From from bottom to top, right? So I'm going to start at the bottom. At the bottom is negative infinity. Again, I'm walking along. And again, I get to this fence right here that I can't jump. So again, this fence is, or that I can't just walk through, right? So that fence is at 0. I make it over the fence, and then I continue from 0 to infinity. Okay, sorry, I just wanted to double check what I had. And then end behavior, we're still using our limit notation. Okay, so what's happening is x goes to the left. Well, as I go to the left, what's my graph doing? Well, before, with polynomials, we always went straight up or straight down. And that's not what we're doing here, right? This graph is getting closer and closer to this asymptote. Right? If I extended this forever, sorry. My blue line is becoming my green line, okay? So my limit as x approaches negative infinity is getting closer and closer to our horizontal asymptote. Same thing here, right? It's getting closer and closer to that horizontal asymptote as well. So if you look, everything comes from where, like, all the important features come from your vertical asymptote and horizontal asymptote. So this one uses your vertical asymptote. This uses your horizontal asymptote. And this uses your horizontal asymptote. Okay, so knowing where your asymptotes are very important. So let's look at an example. So my vertical asymptote, my vertical line is right here at x equals 1. My horizontal asymptote is right here at y equals 3. So then my domain, the only thing interrupting my domain is this one vertical asymptote. So for my domain, I'm going to go from negative infinity until I get to this 1. I have to stop and then restart and keep going. Right? I just can't be right here. I have to get over that and keep moving on. Okay. Same idea for my range. It's going to start at negative infinity and go up until I get to that horizontal asymptote, which is at 3. And then keep moving on. Our end behavior, well, the limit as x approaches negative infinity. Well, again, it's getting closer and closer to that horizontal asymptote, which is at 3. Okay. Same thing on the other side, right? Oh, I have to switch colors. All right, as I go to the right side, right? Again, it's going to get closer and closer to that line, which is at 3. Okay, the last thing we want to look at is increasing and decreasing. So I have to take each chunk of my graph, right? This of my domain, right? So sort pieces of domain. Okay, so my first part, negative infinity to 1. Well, it starts up high and ends at right at negative infinity. It's at almost 3, and at 1, it's all the way down here going past our negative 10. So that started up higher and went lower. This is decreasing. When we look at our other set piece, 1 to infinity, well, it's starting up here and it's going to 3. Well, from 10 to 3, that's going down. That is also decreasing. And therefore, there is no part of this graph that is increasing. Remember, this is called your empty set. All right, and that is it for this example. Let's go ahead and look at our next page. Okay, our vertical asymptote is here. That looks to be at negative 1. Horizontal asymptote is here. That's at y equals 2. One thing is you're trying to figure out, wait, is this one x equals or y equals? My vertical asymptote passes through the x-axis at negative 1. My horizontal asymptote passes through the y-axis at 2. So it's whichever axis it passes through. So then my domain, well, again, I have negative infinity to negative 1, and then 1, negative 1 to infinity, right? Because I'm walking along. Oh, I came to the fence, I have to get to the other side of it before I can walk along, right? So there's my jump, so I can get over that fence that's been created. My range, negative infinity until I hit that fence at 2. I have to jump over it, and then I can keep going from 2 to infinity. All right, then our end behavior, same idea, the limit as x approaches negative infinity of f of x. Well, as I go this way, right, I'm getting closer to this line. So it's at 2, which again is my horizontal asymptote. And my other side is the same thing, the limit as x approaches infinity of f of x. Well, again, I'm getting closer to the horizontal asymptote here of 2. So now I'm going to look at my pieces of my domain from negative infinity to negative 1, from here to here, right? It's clearly going up, right? And then same thing here, right? It was at negative 1, which is down here. At infinity, it's over here. It's gone from lower to higher. This piece is also increasing. Therefore, both of our, right, all of our pieces of our domain are increasing, and there is nothing that is decreasing in this graph. Last example, this one has 2 vertical asymptotes. Okay, so sometimes that does happen. It is possible to have 2 vertical asymptotes. I have one here and one here. It's actually possible to have like a million vertical asymptotes. We won't look at them, but here's negative 2. That is negative 3. And x equals 3. Right in between 2 and 4 for both of those. Okay, so you can have more than one vertical asymptote. Horizontal asymptote, you will only ever have one. This one is also at y equals 0. Okay, so you can never have more than one horizontal asymptote. Then our domain, well, here we have multiple times we have to jump, right? So I'm walking, I'm at negative infinity, and I'm going until I get to that negative 3. Then I have to stop. I get over it, I'm at negative 3. And I'm going, I'm fine, until I get to 3. Then I get over that 3, and I can keep going forever. Okay, so at every vertical asymptote, I have that jump in my domain. Okay. Our range is still the same idea with our horizontal asymptote, which is negative infinity to 0. And then 0 to infinity. And behavior, same idea still. The limit as x approaches negative infinity of f of x. Again, it's approaching, as I go this way, it's getting closer and closer to that horizontal asymptote. Now, this part looks different, but this isn't at our ends, right? As I go to my ends, this is what's occurring. This part has nothing to do with our end behavior. Same thing on the other side. As I go to the right, it's becoming that blue line, which is at x equals 0. Okay. Now our increasing and decreasing, look at our domain. Well, the negative infinity to negative 3 from here to here, I start here and I end up here, that is increasing. Okay. When we have these little shapes here, this is where we have to be careful. Negative 3 to 3 goes up and then goes down. So we have to think about where it switches, and this is just like what we did last unit, right? It's going to switch at its maximum. So if I go from here to here, that's increasing. Right? Because it's going to a maximum. And that maximum is at the x value of 0. Then from my maximum to where this piece of my domain ends, going here to here, it's gone down. So from 0 to 3. And then my next piece, on the left I'm up here, on the right I'm down here, it's gone down. And so now I go from 3 to infinity. Alright, we're going to look at our last computer example in class with Desmos. Otherwise, I will see you guys tomorrow.